One of the key things that XML Web Services brings to the table is essentially this introduction of a new application architecture. This realization that the internet kind of introduces a brand new stage in the development of distributed applications.
As people go to web services and start actually using the web as the platform that they build applications with, the reach and the number of people they hit and sort of the style of coding that they choose is going to change. I think this is a fundamental change in how and why you build applications.
And XML Web Services is probably the first attempt to tackle this problem where, from the very beginning, kind of deep down buried is the assumption that you don't necessarily know what is on the other side of the wire from you.
We were trying to create a platform that is coherent, and it looks like it was developed or designed by one person.
The framework just is really, really nice as a developer to work with. The fact that it's been developed as an entire, comprehensive, consistent framework rather than have one team doing data and another team doing file stuff just makes it all flow better. It makes it a lot more predictable. I can expect how things are going to work.
The exciting thing that we've done is really bring all the development tools into one development environment.
And now when we move into the .NET world, we have this very nice unified model. It used to be you'd choose a language and there was this environment that went along with it. And now you can say, hey, I like a C-style syntax, or I like the way C# is, or I like the way VB is. And you can know that the stuff you write, anybody else can use.
With the new CLR, they all speak effectively the same language in the back end. So interoperability between the various languages that support the CLR is just so much easier.
It makes programming fun again. I can just do whatever I can imagine to write.
You don't have to think about the plumbing of creating your application.
I don't have to kind of write this ugly stuff that I know how to do, but it's just kind of tedious work.
Myself as a developer, I can just come into work in the morning and say, I think I want to do some peer-to-peer networking today. And I don't have to be a genius about networking. I can just go into the networking classes that ship in the .NET framework and read a little bit of sample code and do a couple of little test samples, and before breakfast I will have my first peer-to-peer network ready.
As a project manager, it was just like from heaven, getting a development environment where my developers could really be so much more productive. And even at chip time, we had so fewer regressions because of bugs that we fixed. It was a much more productive environment to build software in.
I've always been a proponent of the zero-based array.
I'm a zero guy all the way.
Zero.
Zero. Everything starts at 1. 0 means nothing.
Everything should start at 0.
Zero-based arrays, one-based arrays. Some people just screamed at us, and some people were very happy, but we had to make a choice.
I don't have an opinion.
I have no opinion.
I think there's a world where zeros and ones can live together.
They're nice people, I'm sure.
For accessing and working with data, I think of the first column, the second column, the third column. I don't think of the 0th column, the 1th column, and the 2nd column.
We're a big company. We can see the differences.
Some of my best friends believe in one-based arrays.
Yeah, I'm a 0.
I've been converted to a zero-based array.
Definitely 0.
0.
I have to admit, I've been broken. 0 is the way to go.
When I was doing VB development, it had to be zero-based.
I have a dream where all arrays are created equal.
I think Microsoft people tend to argue for the sake of argument. I say pick one and move on with it.
Ladies and gentlemen, please welcome back Robert Hess.
Well, welcome back from the break. As you've seen, the ball's already rolling, and we're starting to prepare you with great information about .NET and web services. Now, hopefully, all you guys noticed this morning that on your chairs were these little card game sorts of things. How many people have actually started playing the card game? Well, what I'd like to do is take and invite out with me Darcy Berner to help show us exactly how the card game's played and maybe provide you a couple tips and tricks about it. Darcy?
Hi, Robert.
So what can you tell me about this card game?
Okay, well, theoretically, my job is marketing to developers, and I know how developers love being marketed to. So I was trying to figure out how to constructively spend the money I was supposed to spend on marketing. And what we did was we created a game so that you all could have fun this week rather than actually read things like marketing materials.
So how does the game play?
Okay, well, I could try to explain it, and there are in fact instruction sheets on your seats, but it's a whole lot easier to demonstrate it than it is to explain it. So Robert, why don't we play a hand? The first thing you do is each person chooses 3 cards out of all of the cards that they have to play with.
Okay, I've got 3.
Okay, then you choose a first card, and you place it face down on whatever playing surface you are playing on, chairs, tables, floors.
Wolf vision.
Wolf vision. Once both people have put down cards, you flip them over. Now you'll note that at the top of the cards, there are these numbers, and the first thing you do is you figure out which color lines up. In this case, the green obviously lines up, and Robert's 16 beats my 11. That means it's my turn to play.
That means I won, doesn't it?
Not yet. So I have 4 choices anytime it's my turn to play. I can fold, and Robert gets to take all of the cards that are currently on the wolf vision, but we're not going to do that yet.
Okay.
I can choose to play one of the cards I still have in my hand, and there are 3 ways that I can play it. I can place it on top of my card so that whatever color lines up, I'm ahead in.
So your 17 would beat my 16 then?
So my 17 would beat your 16. I could place it on top of my opponent's card so that whatever color lined up, he would lose in.
So that means my 2 loses out to your 13.
Exactly.
That's cheating.
Or, if the colors match exactly, that is, if the order of the colors is the same, you can actually do an additive move where 11 plus 17 is 28. That beats your 16, Robert.
So I've got to beat a 28.
You have to beat a 28. Now you have your 4 choices. You can forfeit now, and I'll take the cards.
What if I go like that?
Oh, well, okay, that's a legal move. Now your 16 beats my 9. So I'm going to play my trump card. Steve B, 15 beats your 7.
So then if I play my Bill G, that means my 15 beats your 14.
Yes, and you get to take all the cards. They're yours.
This is fun.
Okay, so there is a point to all of this. In addition to having fun, we're giving away more than $15,000 worth of prizes this week, including the grand prize of an Xbox. I heard how you all got excited in the last session about Xboxes. So we are giving away an Xbox. The way that you win the prizes is among the cards, there are these code cards in various colors, green, red, blue. Each set of code cards has 5 cards. If you can figure out the puzzle...
Let's see, can you bring the wolf vision back up? There you go.
There we go, code cards. If you can figure out the puzzle demonstrated on a set of code cards, and you're one of the first 10 people to do so for that color of code card, and you bring your code cards and the answer to the puzzle to the head-to-head information desk, which is in the front lobby, then we'll give you a bunch of prizes. If you get all 3 sets of code cards and you figure out the big puzzle, you win the Xbox if you're the first person to do it.
So what's the answer to the puzzle?
Wouldn't you like to know?
Oh. Well, thanks, Darcy.
Thank you,
appreciate
Robert.
the information. Hopefully you got some tips and tricks that'll help these guys be a little more strategic about their game playing.
My first piece of advice, try to win on the flip.
Okay,
Thanks,
Darcy.
Robert.
So it'll be interesting to see just how many people out there start playing this game and spending all their time in the hallways trying to beat each other on the cards. So go ahead and play those games, win that Xbox, and the other prizes out there available. Well, now I'd like to take and introduce the next speaker. We have Eric Rudder, Senior Vice President for Microsoft, here to talk to us about .NET services.
Well, good morning. Thank you for coming. I think it's important to take a stand on the hard issue, so I kind of label my title slide, slide 0. Before I get started, how many of you were actually at the PDC last year? Maybe you could applaud. It's hard to see up here. That's good. How many of you actually played with Beta 1 or Beta 2? That's pretty good. And how many of you have actually written and deployed your first web service? Well, that's pretty good. I think we're going to have some fun today. I'm going to quickly recap on the 3 pillars that Bill touched on: XML web services, client-server services, and great user experience. I'm going to spend most of my time giving a technical overview of .NET, drilling into the .NET framework, talking a little bit about performance and security, and showing you how we use the framework in actually how we take and build the .NET My Services. And then I'm going to actually touch on .NET Futures and kind of give you a sneak peek at some stuff we're working on in the future. Well, what are the three pillars? Bill clearly laid out XML Web Services as a huge bet for us. It's truly our next generation app architecture, and we expect it to span implementations, because obviously it's built on a standard foundation of specs, organizations, and geographic boundaries. Applications are being composed of clients, servers, and services. And the .NET framework, which I'm going to talk about in a few minutes, delivers a unified programming model for building these next generation of solutions. And in fact, as you build these solutions, the solutions themselves become application networks. So you actually might build a solution and then take that and expose it as a web service. And we'll talk about some examples. And finally, I think it's important to note that the great user experience really prevails. You know, customers buy great solutions. And in addition to being anytime, anywhere, on any device, truly exploiting the capabilities of the device to its full potential is key to building great solutions. So the application architectural model is starting to change. As this slide shows, you can kind of see your application will start to be composed of clients, servers, and services. And the .NET framework is the fabric that ties it together using XML Web Services. You know, historically, we focused on building nodes, you know, kind of one of those little rectangles. And really now, we're moving to an environment where we focus on building systems. And I think, you know, in addition to thinking through how your architecture is going to change and how you build your applications and solutions, I think it's important to think about the opportunities this presents to you as an ISV as well. You know, in the past, ISVs have clearly sold apps, they've sold components, and I think it's important to think about how you're going to sell services to other ISVs as well. Well, Bill hinted at some of the business benefits of web services, but I want to explicitly outline them. The first is clearly, we think it's best of breed business integration. And one of the things we designed web services for is to make sure that we could really stitch together these technology islands, right? That, you know, if you deploy into a corporation, there's clearly legacy databases, connectivity, and we made sure that the connectors are there so that web services can fit seamlessly into an organizational environment. The second point I really want to highlight is that federation provides a consistent model, but that organizations actually control their own information and applications. I think there's actually been some confusion on this topic, and people are afraid, oh, if I start using services, then Microsoft's going to own all my information. That's not true. When you take Windows.NET Server and you federate using open published specifications for Kerberos, you as the corporation actually control at the boundary what information stays inside, what information gets shared with others. So we'll give federation control points of presence as you develop your solutions. The second set of business benefits is really that web services are resilient, and they're resilient in a couple different ways. One is they're resilient to changes in implementation. Clearly this is important because not only are we implementing web services, but you know, the industry ecosystem is moving to web services as a whole. But as we upgrade, as you change how you deploy your application topology, so say that you get a lot of load and you start to add servers, right? Clearly you want your web service to keep functioning. And the converse is also true. You might decide you want to do server consolidation, and still the web service should continue to function. And finally, it's resilient to some technology choices that you make. All the work we do in the .NET framework actually gives you a choice in what transport you use and what encoding techniques you use as well. Well, let's take a simple scenario and see how web service can actually be used in many different contexts. Say you build something like a quote engine. You might start out using it in a typical internet client-server application. You know, here I've sold like a call center client. So if somebody calls up, they want a quote or information about rate, your client app typically calls the quote engine and you can quote the rate over the phone. But what happens, let's say you have a mobile sales force, right? Those guys are out on laptops, they're disconnected, they're offline. You can actually take that same web service and use it to build your offline mobile solution. Well, say business is expanding, this e-commerce stuff is great, and you now actually want to gain distribution by having partners sell your products. But you want your partners to quote the right prices. So you can actually take this web service and expose it over the internet and publish this information, publish this application to a partner. I think it's important to think that about how the web service architecture is more than just calling services over the internet. It's more than just services in the internet. It truly is an architecture that will span many different scenarios. Okay, well, enough talking about web services. We're at the PDC after all. I think it's kind of time to see more code. I'd actually like to invite Scott Guthrie out to see how the .NET framework and tools work in action, building on some of the work that Anders did this morning. Welcome.
Thanks.
So what are we going to do today?
Well, earlier this morning, Anders Hausberg walked us through building a simple XML web service built using ASP.NET and C# that exposed some orders data from the Northwind database. He then went ahead and built a client front end using Windows Forms that called that web service and exposed that data. What I'm going to do for the next couple of minutes is extend that scenario even further, this time building some server application front ends that actually also call a very similar web service and present and interact with that data. I'm going to build everything in Visual Studio.NET, but just to show how easy it is with ASP.NET, we're just going to go ahead and actually build the entire applications from scratch, targeting both desktop browsers as well as mobile devices. I'm going to type in all the code in front of you, no application templates, no copy-paste. You're going to see everything on the fly.
Okay. So we're flying without a net here.
Flying a little bit without a net. Which language do you want to use?
Well, I don't know. It's kind of it's an audience involvement thing. Maybe the audience should choose which language. C#, VB. Sounds like VB to me, I think.
I heard C#, I heard COBOL, I heard Fortran.
I promise later on we'll get the COBOL fans their fill in later on in my talk.
There's 25 or so languages you can use. Some of those that were mentioned are ones that I actually know. And so we're just going to kick it off. What we'll do is we'll do two languages. We'll do the first demo in C#, and then we'll go ahead and a little bit later, VB. It would be interesting to watch me do COBOL on stage for both you and me. But anyway, let's go ahead and kick it off and actually do it in C#. So set up the scenario a little bit more. We're going to go ahead and hit a Northwind web service. This is very similar to the one that Anders showed you earlier today. I've made one modification, which is that his web service, he had a get data method that you could pass any arbitrary SQL data and get back, execute a result and get back some data. What I'm going to do is I modified it slightly to make it a little bit more realistic and instead just have a get orders method off this web service. And what I do is it allows me to type in a date. It'll go ahead, hit the database, execute a query, and return all the orders that were placed on that specific date. So what I'm going to do to begin with is go ahead and build a front end for a desktop browser app that calls that web service and presents some simple UI for me to interact with. So to do that, we're going to use Visual Studio.NET. I'm going to hit New Project. We're going to use C# as our language. We'll select ASP.NET Web Application down here. Hit OK. This is going to go ahead and create a project template for me to use, create a blank page for me, and at the same time register this application with IIS. So I'm good to go. Now I have a blank page here. So what I'm going to do with this page is build some simple UI. It's all going to be HTML, which means it'll work against any browser device, whether it's IE, Netscape, Opera, on any client operating system. There's no client smarts required. We're going to make this the Northwind order history page. Format it to look somewhat pretty. Since I want to go ahead and pull up orders for a specific date, first thing I'm going to do is say, hey, select the date. And what better way to select a date than let's drop a calendar control. It'll help automate it for us. Now this is what we call an ASP.NET server control, which means it's declared in a tag, in this case the ASP calendar tag, with a run@server attribute. And what will happen at runtime is ASP.NET will parse this tag, create a .NET class that represents it, and we'll have a class that's actually running and representing the calendar on the server that we can interact with. I can set styles on it using the property grid, or because I'm not much of a designer, I can pull some simple styles or pre-formatted styles that someone who has design taste has actually come up with. I'll make it look attractive there. So what I'm going to have someone do is select a date. We're going to write some code in a little bit to call a web service. The last thing I just want to do, though, in terms of UI, is drop an order listing. So once I get that order data back, I want to go ahead and display it. To do that, I'm just going to take the standard data grid and also format it to look a little pretty. Make that bold. Now I have all my UI defined. Now, next thing is to go ahead and call that web service. To do that, let's go ahead and actually add a reference to that web service into my project. It's going to go off, pull down the SOAP contract for that particular web service, and import it into my app. Now, that web service happened to be built with ASP.NET, but it could just as easily be built with any vendor that supported SOAP and OpenXML. It's not tied to any specific platform. Now that I've imported that web service, all that remains is for me to write the code. To do that, I'm just going to double-click, add an event, server-side event handler on that calendar control. You notice, even before I type, that the code is actually cleanly separated from the HTML content so that I can have my developers and my designers working together nicely. All I need to do then now is let's go ahead and instantiate that proxy object to that web service that we created by adding that web reference. And I'm going to go ahead and call that proxy method called getOrders, again using statement completion. And I want to pass in the date that I want to get the order information for. To do that, I'm just simply going to say calendar1.selectedDate, return the selected date, and we'll just go ahead and data bind this to my data grid, cause it to data bind. Hit save. Go ahead and hit build. Let's go ahead and run this. We only added 3 lines of code, but now I have a simple UI page, and when I select a date, we call a web service and bind the resulting data. It works with any browser device because this is just standard HTML being sent down.
That's pretty cool, but I hear all this talk about supporting smart devices, and it's nice that we have great WinForm support, browser support, but show us some device support.
Sure. So what this page is doing right now is it works against any what we call desktop browser. So things like IE, Opera, Netscape, where you assume that the screen that's going to be displayed is a fairly decent size like we have up here. There's a whole other class of devices that is emerging, which are mobile devices, very, very small form factors, maybe 2 inches by 3 inches in terms of screen size. And obviously something like this page isn't going to look that great on that kind of device. The good news, though, is with ASP.NET, we have built-in support via a set of what we call the ASP.NET mobile controls that are available as part of the ASP.NET Mobile Internet Toolkit that I can go ahead and download that makes it really easy for me to target those types of form factors. And in fact, we even have a simple project type that you can use inside VS to target those. And so that's what we're going to do now is build this exact same thing. We'll use VB this time. I heard a few people call it VB. And I'm just going to say create a new mobile application. This is going to create another ASP.NET application for me to use. It's going to predefine a page that's using the mobile ASP.NET server controls. And all I'm going to go ahead and do now is basically build that same UI, this time targeting a small device. Now, a couple interesting things about small devices. One is, as I mentioned earlier, they have very small screen factors. So rather than put all that information, both the calendar and the grid on this page, what I'm going to go ahead and want to do is actually separate them up into 2 what we call sort of form elements on the page. One of which we'll use to actually select the date. The other one we'll use to basically display the resulting orders. The other thing about mobile devices is that they don't all support HTML. A lot of them support, for example, WAP, WML, or HTML, or a variety of different sort of markup formats, which means that if I want this page to truly work against any device, I can't build in HTML smarts. The good thing is, though, our server controls automatically encapsulate those differences for you. So I can just set this label guy on here, let's say Northwind orders, set the style to be a title, and then if it's on an HTML device, it's going to output sort of a bold title-like font using, say, maybe an H1. If it's on a WAP cell phone, it'll actually use it in the appropriate markup for that device as well. Then I'm going to go ahead and drag and drop my calendar again, and a list control on that second form tag. Import that web reference to that web service. Download and create that proxy object for me just like before. double click, and then go ahead and write my event handler. This time it's in VB, so let's see, dim proxy as new localhost.northwind. Call that method just like before. In the last step, so it's basically the same 3 lines now in VB, was once in C#. The one additional line I'm going to add is because I have those 2 form elements, I just need to go ahead and remember when I select a date, I'm going to change the active form that's displayed to be the second form, which is the form results.
So even though you have multiple pages, you're actually able to keep the same code, and the server understands the page scope.
Correct. Yep, absolutely. All I need to do now is then build, and I have a mobile app. So let's go ahead and test it out. I'm going to go ahead here and test it out on a variety of different devices. The first one I'm going to use is a Pocket PC device equipped with a a wireless little card here, so I can go ahead and walk around stage if I wanted to. I'm going to keep it here so you can see it, though. And all I need to do, hit that page. It's going to make a call to my web server. It's going to display the simple page. I haven't formatted the calendar quite as prettily. You can do that, obviously, to make it a little bit cleaner. But what I can go ahead and do now is simply select a date. It's going to pull up a listing of my orders. Click on a specific order ID, and it's going to go ahead and actually drill into those details and actually, again, call that web service and display the resulting data on the screen. So that's one particular form factor, a Pocket PC. We've already seen a browser. Now we've seen it on sort of a nice 3-inch by 2-inch screen. There's yet another type of form factor, which is even smaller, which is sort of, for example, a cell phone. And there's billions of them out there, or millions of them out there, and they're growing every day. It would be great if I could take this exact same app and go ahead now and display it on a cell phone. Well, the good news is if I target using ASP.NET and the mobile controls, I can actually do that. And that's what I have up here right now, is I'm going to go ahead and run a simulator, a phone simulator, built by a third party called OpenWave. And what you're seeing here is there's sort of a little skin that actually looks like a phone. But inside this little display, it's actually calling my web server, getting back. In this case, it's saying it's a AT&T cell phone that supports WAP. So it's going to go ahead and actually displaying WML in this device. And it's just talking to my server where all my logic is actually living. Now, the screen on this particular cell phone is very small. It's not nearly as big as the Pocket PC or a desktop. And as a result, I can't actually display a calendar to select that date. So what the calendar control's done, though, is it's smart enough to go ahead and say, OK, I don't have enough real estate. Instead, I'm going to have a UI that makes a lot more sense, which is the ability to just select the date using your phone itself without having sort of a calendar paging-like UI. I didn't have to write any code to do that. It's going to give me the option of today's date, lets me type in a date, or I can go ahead and just choose a date. This is sort of ideal where I have an up and down key, but I don't really want to have to type something in on my phone. I can just drill in here, select a date range, pick a date, goes back to the server, calls that particular web service, saying, hey, I have 3 orders, and now I can select an order and pull up and actually see the order details on my phone.
Well, that's pretty cool. So, and the server was doing all the make-it-right work for the client.
Yep, the server did all the work. It doesn't require any smarts in the client, so it'll work with any phone out there. Likewise, for the Pocket PC, it doesn't require any smarts, as well as the desktop, so it works with any device. The total lines of code you saw up here, the build the desktop app was 3 lines of code that you had to write, and for the mobile app, you only had to write 4 lines, and now you can literally target millions of devices out there.
Well, next time I'm going to make your work harder.
Thanks.
Thanks, Scott.
Thanks a lot.
So I hope Scott gave you a little taste for the fact that we think ASP.NET is ready. In fact, one of the things we're happy to announce is actually MSN.com will go live this week on the ASP.NET technology. Well, Scott showed how web services can be used in many different contexts. And it's important to think it's important to note that we think about web services in many different contexts as well. We focus on clearly thinking about scaling away, right? Web services spanning organizations and geographies. And this has kind of gotten most of the attention. But we also think about scaling out, right? How can you take a web service application and just by adding machines scale the number of clients that it supports? We think about scaling up our large subsystems. Paul Fleshner will show some numbers for our scale up on the Unisys E7000 that are pretty impressive. We think about scaling in on a machine, right? This is kind of the laptop scenario where you have an application actually calling the web service within a single box. And of course, we think about scaling down to devices. So when we think about taking web services everywhere, scale means a huge variety of challenges for us as we take this application architecture forward. Well, while we've done a lot of work to make XML web services a reality, the truth is there's still even more work to be done. And today, I'm happy that we are announcing the global XML web services architecture to help take XML web services to the next level. This architecture provides a coherent, general-purpose model for adding new, advanced capabilities to XML web services. Today, people are having a lot of success with XML web services, but there are still some things that are left as an exercise for the developer. For example, security, transactions, reliable messaging. The global XML web services architecture gives us a modular, extensible, composable way to add additional capabilities like these. As part of the architecture, today we are posting 4 new specifications to our website: WS Security, WS Referral, WS License, and WS Routing. We intend to standardize all of these protocols just as we have the previous XML web service specifications. The architecture also provides a common reference for future capabilities. Let's take a look at what this looks like. At the lowest level, the internet and the web is great infrastructure. And with the introduction of XML, it became possible to exchange much richer semantics between organizations. And Microsoft worked with IBM and many others in the community to create SOAP. And truly, SOAP is as important for application-level communication as TCP/IP was for networking. It turns out just exchanging SOAP messages isn't enough. To be a viable basis for application development, we need reflection mechanisms, just like we have in modern programming languages. We worked with others to describe the messaging endpoints in WSDL and to provide mechanisms for finding these endpoints. Microsoft was also a leader in defining a white pages-like mechanism, DISCO or newly renamed WSDL, and a yellow pages-like mechanism, UDDI. So this kind of box over here, this is what lets the IDE take advantage, auto-generate those proxies, provide features like statement completion and directory, and they're a key part of expanding the web service architecture. Since we introduced .NET, we've been talking with you to identify best practices in security, messaging, and large web service-based applications. And we've taken this feedback that you've given us, and we've actually built these mechanisms into our runtimes and servers so that you can use them broadly. In other words, we've taken on more of the responsibility for building the plumbing so that you can focus on building your business logic. Above the web services and these new modules that we've been working with the industry to create, we're also hard at work creating infrastructure that makes it even easier for applications to work together. So reliable messaging looks at the corner cases to make sure that you don't lose information during business communication. Eventing makes it possible for web services to alert the client when there's changes in the service. It takes away all these polling loops that you have to do today. And finally, we're working to address the huge challenge of enabling transactions across organizational boundaries. Well, again, I think sometimes the demo is more exciting than looking at the PowerPoint architecture. So I'd like to invite Vic Condotra out here to show you how global web services can help you build your application.
Thanks, Eric.
Hey, Vic.
You know, XML web services have taken the industry by storm. And it's very exciting to see how system vendors like IBM, Oracle, even Sun has endorsed and are supporting the XML web services model. But as Eric pointed out, there's so much more we can do to move XML web services standards forward. You know, we can and we will make that underlying infrastructure, that fabric, more capable. And thus it allows developers like us to build cooler apps, more functional apps on top of that. What I'm going to do this morning is highlight some enhancements that Microsoft is working on in partnership with the industry to move that XML services standard forward through the Global XML Web Services Architecture, GXA. I'm going to focus on 4 areas. I'm going to talk about improving performance, security, routing, and finally, reliable messaging. So let's talk about performance. You know, as everybody knows, the SOAP version 1 specification described sending SOAP packets over HTTP. And obviously, HTTP is widely adopted. It's on everything, mainframes, PCs, cell phones. And that's contributed to the success of SOAP. But of course, there's some limitations. HTTP has some very significant performance limitations. It requires me to, for example, send binary information as text, right? I have to do base 64 encoding on the server. I have to decode it on the client. Further, you know, I have to layer a SOAP on top of HTTP. Imagine, though, if you could put SOAP natively over TCP or UDP, and you didn't have to worry about doing the conversion from binary to text, and you didn't have to do expensive parsing and buffering. Well, that's exactly what a new proposed standard, DIME, does. DIME stands for Direct Internet Message Encapsulation, and it provides the ability to put SOAP natively over TCP and send binary transfers without having to worry about all that parsing. Let me give you a demonstration. What you're looking at on the machine here is a web service that goes out and calls an image archive. And it calls that image archive and it brings down these images. You can see the SOAP request and response that I'm calling out to get those images. This is using standard SOAP today. You look down here at my SOAP response. You see where that cursor is? Look at that body. You can see that that image is being converted over to ASCII to character. I'm doing that base 64 encoding, incurring the cost on both the server and the client, and bringing that down and parsing, looking for the end of that stream. But keep your eyes on the image as I enable DIME, and watch what happens. You can visually see the performance jump we get right away. How did that happen? I'll show you the 3 things. Let me stop this. Number 1, I've added that DIME header into my SOAP request. And then in my SOAP response, you'll note I'm getting the binary image back as well as the payload length. So no more parsing. These simple enhancements can dramatically improve performance. Let's talk about another area. Let's talk about security. You know, clearly you've seen in the demos, in Bill's talk and in Eric's talk, creating a web service has become very, very easy today. But getting a bunch of web services to have a common mechanism to do secure access and authentication, now that can be problematic. Not that it's not possible, it's just that everybody does it their own way. Some people use SSL, others might use something like public key X509 certificates, and so there is no standard mechanism to provide end-to-end security. Well, the new proposed standard called WS Security proposes to solve that problem by putting right into the SOAP packets themselves a flexible architecture that allows you to embed the security credentials. Now, WS Security doesn't mandate a particular algorithm. If you want to use Kerberos or public key or clear text, you can do that. In fact, let me show you here. You note that the images that were coming down had a watermark on them. Obviously, if that's what this web service serves up to an anonymous user. But if you're authorized, well, you get those images without that watermark. So I'm going to go ahead here, and using WS Security, I'm going to type in my credentials. I'm going to use a public key mechanism, and if you look at the SOAP request header, you'll note that there is my WS Security header. You'll note that I'm using an X509 certificate, and there embedded in the packet is my certificate, my key. Let me switch over to use something like Passport, which, as we pointed out, we'll use Kerberos. And so, sure enough, look at my header, change to Kerberos, and there is my Kerberos ticket right within the SOAP header. So I'll go ahead and log in and start. And hopefully I'll get authenticated here. There you go. And I'm getting the images without the watermark. So hopefully you can see how WS Security starts to provide us an ability to build web services that cross organizational and trust boundaries. Pretty cool. All right, let me move on to another thorny problem, and that's the problem of name resolution. You know, imagine for a moment that you have two web services built by two different companies, and those web services need to call each other. Now imagine that, as you might expect in the real world, those two companies have their respective firewalls. Well, when you try to make that call to that company, the other company's web service, what happens? Well, you can't do it. The name doesn't resolve. Because of the firewalls and the network address translators on both of those companies' sites, why, it's impossible to make those things connect. You know, the problem is even worse for consumers. If you're trying to build a peer-to-peer consumer application, think about what you have to face. You know, you have someone at home who's got a machine. Maybe you're connected via DSL or a cable modem. You write a web service. You try to expose that to the outside world. What happens? Well, chances are your service provider, your cable or DSL provider, has a firewall, a network translator, that prevents the name of that web service from being globally available on the internet. Heaven forbid you have a firewall at home. Now you've got a double layer of indirection. You've got another network address translation problem within the home or the office where that web service is set up. Let me illustrate that problem. Let me switch over to another machine. Okay, what I've done is this light bulb here is connected to a machine via an X10 controller, and as you might expect, we've written a web service on the local host that toggles that machine, that light on and off. So in fact, I'm going to flip the switch here on and off, and you can see from this local machine, I'll try it on again, I can enable that light to turn on and off. I'm going to switch to a different machine now. This is the local machine driving that. Let me switch to a different machine. And bring up, let me close this, and bring up that same application on this machine. So we're going to make that web service call to the other machine now, and we're going to toggle that light bulb on and off from the remote machine, just making a web service call. Okay. I got an error. What's going on? Well, what we did was we put this machine behind a NAT. And thus, when we made that call, the name was not resolved. You can't resolve the name. And so you get an idea of the problem we face. Well, a new standard called WS routing and WS referral, these two standards work in conjunction to solve this problem. What they do is they embed within the SOAP packet the handoff route. Certainly, the firewall knows about the NAT knows about my machine, and thus, if we specify the appropriate handoff to the final destination, why, it can work. So I'm going to enable that header. You can see it being inserted into my SOAP request there at the top. Of course, if I'm going to go through that firewall, I want to add the appropriate security header as well. And now I've added that to my SOAP request. Let's see if that light works. Let's cut it off. There you go. Okay? Now, let's keep moving on. What else can we do to the underlying infrastructure? Well, let me start cycling that light bulb. I'm going to ask that light bulb to go on and off a few times, but I'm going to throw a curve into it. Taking the network cable, I'm going to disconnect it. Now, I've disconnected the machine and from the machine that controls the X10 controller. When I connect the network back up, what happens? I think there was a series of messages left to go. That light didn't blink 10 times. Nothing happens. What happened to the rest of those messages? Well, obviously, they just fell off the end of the net. They're lost in the ether. Now, if you as an application developer want to solve this problem, particularly if you've got messages that are far more important than turning a light bulb on and off, you have a lot of work to do. You've got to think about how do you queue up those messages, how do you guarantee against loss, maintain ordering. Well, WS Reliable Messaging works to solve those problems. What this does is it builds that into the underlying infrastructure, and it guarantees message delivery, message order, and prevents against duplication. Let me turn that on now. Okay, you can see here, right there that's blinking, I'm adding that header to the into the SOAP request header. I'll restart that cycle, and the light continues to go. In this case, I'm going to disconnect Okay? Just as last time. The messages have been sent. But this time, watch what happens. How cool is that? Dime can give you better performance. SOAP security can start to allow you to run through organizational and trust boundaries, giving you a common model for a flexible but standardized model for end-to-end web services security. And finally, you saw there with WS reliable messaging, we're really working to make that underlying infrastructure robust against message loss. Thanks, Eric.
Thanks, Vic. So I think Vic really showed you what global XML web services can do. And hopefully that demo also illustrated the importance of having a rich XML web service architecture that's composable, right? So for example, sometimes you need reliability but not security. Sometimes you need security but not reliability. Sometimes you need security, reliability, and performance. And you, as a developer, get to mix and match the capabilities that you need for your web service moving forward. Well, let's take a deeper look inside the .NET framework, the .NET framework, which is what we use to build these services. The key thing about the .NET framework is that it provides a unified programming model. So not only do we deliver XML web services, but we have one way to write code that spans clients, servers, and services. So you don't have to learn a complete new class library every time you start to develop another part of your solution. The .NET framework was designed for developers and to maximize developer productivity. That means design time support is actually built into the framework itself. So when you see those fancy tools doing cool layout things and cool wizards and builders, that's all built into the framework itself. And we made sure that we focused on the hardcore plumbing so that you can focus on the higher level services for your users. The .NET framework provides for simplified deployment and maintenance. You saw some of the zero-touch deploy in the first demo. Great performance, and we provided an intense focus on security, and I'll talk about each of these moving forward. Well, sometimes we think about the .NET framework as including four parts, kind of a core, presentation services, communication, and data. The core technologies really span all the areas of the framework. There are things like our component model, the fact that we use XML throughout the framework, transactions, and our focus on the abilities, scalability, reliability, manageability. The component model really lets developers focus on their code, and it enables this industry of partners where you can mix and match components to help build your solution. XML is used everywhere. We use it for serialization. We use it to store the documentation, the data schema. We use it for configuration. It's XML through and through, not bolted on. Security is designed into the core engine itself. We monitor every operation, and we enable security enforcement at a very granular level. Presentation, I think the key here is that we enable both rich and reach using the same model, and you've seen that in some of the demos today. The data benefits, really the key there is that we provide the best of relational and the best of XML while preserving transactional integrity and providing access to any data source. And the communication benefits. Clearly we focus on making web services simple, but sometimes you actually need to hit the metal, and our communication framework actually covers the full spectrum. So if you need access to raw sockets, that capability is in the framework. Well, the core of the .NET framework really is the common language runtime, or what we call the CLR. Fundamentally, it provides for multi-language support through a common type system. It allows for the simplified deployment. It enables code access security. And fundamentally, the framework and libraries are designed to make it easier to navigate, discover, and leverage your existing knowledge. The CLR is designed to completely eliminate COM plumbing. So there's no more registration, no more GUIDs, .idl files, H-results, IUnknown, addref, release bugs, all that goes away. And finally, it's important to note that we're actually standardizing the CLI, which is a subset of the CLR, through ECMA. And I'm actually proud to announce that the technical committee is actually on track for a mid-December General Assembly meeting where we'll actually publish the specs. Okay. Well, we provide for broad language support. You've seen VB, you've seen C#, you've seen C++ today. Some of you may know we even announced support for the Java language targeting the .NET frameworks last week. Here's some similar examples using scripting. You could applaud for your favorite language when it hits the screen. So for people who like JScript, Perl, or Python, those are all supported. I promised we'd get into some COBOL code. I don't want to drill too deeply on this. It's been a long time since I actually earned money writing COBOL code. Actually, I earned more money writing RPG3. We could have a breakout session on that later. But we support RPG, Fortran, a whole bunch of business languages, even APL and Smalltalk, and even some of the more experimental languages like Scheme, Eiffel, and Mondrian. So, as Scott mentioned, we have over 25 languages that are currently under development using the .NET framework and the CLR. And the important thing to note is that truly the greatest language minds in the world are working on .NET, both at Microsoft product teams, folks like Anders Heilsberg, Stan Littman, who's a C++ pioneer who just joined us, Andrew Klinick, Scott Wiltemuth, Peter Goldie, Eric Meyer, Greg Meredith, Chuck Mitchell, Patrick Dessou, true language pioneers. Also, we have an incredibly talented staff at MSR, Microsoft Research, folks like Simon Payton-Jones, Luca Cardelli, Dave Hansen. These are world-famous scientists. And in conjunction, they're working with the greatest minds in the industry, folks like Bertrand Meyer, Hal Abelson, Martin Ordersky, and many other scientists throughout the world. I think the thing that they really like is that the .NET framework and CLR makes it so easy to experiment with language syntax, language constructs, language runtimes. And I expect lots of language innovation to continue to pervade the CLR in everything we do. So it's nice not to have a static, fixed language that you can't change and develop around. Okay, let's take a look at what happens when you actually write some code and how it winds its way through the CLR. Clearly, you start with source code. You pick your favorite compiler, be it C#, Java, VB, or COBOL, and we produce something called an assembly. And the code is actually stored in a format, an intermediate language that we cleverly named MSIL. I'll let you guess what it stands for. And metadata really is one of the key architectural elements that's stored in the assembly, right? All the stuff that was previously scattered all over the place from COM, the registry info, the type libs, they're now in the assembly. Okay, so after you've done your development and hopefully compiled without any errors, it's time to do deployment. And we basically give you 3 separate options for deployment. You can actually write a traditional installer and install to the global assembly cache, sometimes called the GAC. And the global assembly cache enables versioning support. And so you can actually have different apps bind to different versions or the same version of the same component. So for a large solution where you might be sharing components across many different solutions, you actually might want to use the global assembly cache. We also allow you to deploy to an application directory. Just by simply X-copying the files, you can actually deploy your web applications. In the case of this type of solution, we actually won't use component sharing, we'll use side-by-side. And finally, we actually allow you to install just using the browser. And here we actually use the download cache that the Internet Explorer uses. So you get the same benefits for incremental download, the caching, and the Internet security zones are leveraged as well. So I think it's nice. That's a case where one of the things we've tried to do as we develop .NET is take the best of Windows and the best of the web and marry them together. And I think we've done that through installation. Okay, well, you've built your code, you've deployed it. It's time to actually take a walk through the CLR and start executing the machine, executing your code. So the first thing is at execution time is we'll actually hit the assembly loader. And the assembly loader is responsible for locating the correct version of your assembly based on the application configuration and machine policy, right? Administrators have a say in how these applications are deployed and what components they'll allow solutions to run with as well. The security engine then constructs a security policy based on the enterprise settings, the machine settings, and the rules in the application itself. It grants permissions based on what the assembly asks for, the evidence, and determines the security policy. The class loader is basically what you'd expect. It's the piece of the runtime that literally loads the class into memory. If necessary, we then invoke the IL to native compiler. And this is simply the piece of technology that's responsible for converting this intermediate language into native code so that we run at the best performance. And again, the developer has a choice. Compilation can either be done at install time, or you can actually do it at runtime on either a method-by-method basis. So your code's kind of compiled into your exe. We have the garbage collection table up. The next key piece of the system is the code manager. And the code manager is actually the interface between the running code and the runtime system itself. So it's sort of the guy in the middle that allows the runtime to safely interrupt program execution and inspect the execution stack. So it works in conjunction with the security stack, right, to control access to native resources. It works in conjunction with the garbage collector. Since we understand the layout of objects, we know when they're no longer needed. The code manager works with the exception manager to provide a two-pass exception handling model. So in the first pass, we actually use the code manager to walk the stack and determine who should handle the exception. And if there are no handlers, we pass control to the debugger without altering the state of the program. This allows for much more effective diagnosis of what happened if you compare to some other VM environments out there that have a single-pass exception handling model. And finally, the debug engine provides the interface to external debuggers and profilers to control and monitor program execution. And these are all documented interfaces, so not only our tools, but the rich partner tools use these interfaces as well. Okay, let's finish our drill down on the .NET framework. So we've talked about the core. Presentation is kind of simple. We take Windows Forms and we provide the richest framework for Windows applications. We have advanced features like visual forms inheritance, which we actually didn't demo today yet. Automatic layout, it's truly a world-class forms package, and I think you'll really enjoy working with it. ASP.NET is our web forms-based model. It's component-based, and it's a page architecture, and clearly, I think you've seen today that the model allows rich and reach without requiring you to learn new code techniques. And we talked about the mobile toolkit and how it enables you to target a broad range of mobile devices. The communication services focus on providing support for ASP.NET and web services through HTTP messages. System.remoting is a part of our class library. That's actually a full-fledged object remoting system that is both transport and format independent. It allows for multiple call patterns, so if you want stateless call patterns or stateful call patterns, there's full type support. Out of the box, it works over TCP or HTTP. We support SOAP and binary formats. And all these things are designed so that new protocols or encodings can easily be added if you wish to subclass for some reason. System.NET is in some ways an unfortunate naming part of our class library, but it's actually the part where the key network protocol stack innovation occurs. So again, we support low-level socket access, support for TCP, UDP, IP multicast, all those low-level bithead things. And it also has support for high-level protocols like HTTP, NNTP, SMTP, and P2P protocols can easily be added again by subclassing. And of course, system.messaging allows for reliable guaranteed delivery, fully transacted. The data part of the framework, probably the key construct in ADO.NET is the data set, and it's an in-memory buffer of related tables. You fill them from managed providers or XML. If you use managed providers, we actually will give you stream-level access to data sources. And I'm actually proud to say ADO.NET actually wound up being the fastest way to access SQL Server when we were done tuning all the performance. System.xml provides great support for XSLT, XPath, XSD, and DOM2. We actually have great performance on our XSL stuff. I'm actually proud to announce that we actually have the best marks on the SSLT mark bench suite, second only to XML 4.0, which we launched today, our native implementation. So we're quite happy with the work that we've done in this class. I think the key benefit really is kind of the holy grail of combining XML and relational together. And if you look at the work we've done with XSLT and XPath, it works against either the DOM or the data set. So we actually allow you to do XLT transforms on relational data, which is kind of a neat benefit. Well, we took all this great technology and we made it available on some new platforms. So one of the things I'm happy to announce today is the .NET Compact Framework, which you have in your voluminous 6 CD pack. The .NET Compact Framework is a compatible subset of the .NET Framework for use on smart devices. The design metrics were really to provide the richest user experience. So use all the local intelligence and data that these devices provide. Of course, bring the great developer productivity to the Compact Framework. So you just use Visual Studio.NET as you would with the regular framework, and you get advantage to all the features, statement completion, the build system, project system, everything. And it was designed for broad device availability. So by this we mean across a variety of physical form factors, across multiple CPUs. It's got an OS portable architecture. You'll see us deliver the .NET Compact Framework on Pocket PC 2000, and on our next generation Pocket PC, it'll actually be built in. Well, I promised I'd talk about performance as one of those cross-cutting areas that actually pervades the entire .NET framework. But rather than having me just rattle off a bunch of statistics, I thought it'd be fun to actually have a developer share his experience from working with the platform. So here to share what he's learned is Scott Stanfield from Vertigo Software. Welcome, Scott.
Hey, Eric, how you doing?
Good.
Now, I'm one of the zero-based array programmers.
Oh, good.
But what I think the real argument is semicolons. I love semicolons. There's something comforting about the way they support the end of a line, like a little caboose. Well, we do a lot of C# development in our company. We also do a lot of Java programming. And I'm excited to tell you about a project that we just recently completed, where we took Sun's Java enterprise reference architecture. It's described in a book called Designing Enterprise Applications, the Java 2 Platform Enterprise Edition. They have a little program called the Java Pet Store. And we thought this would be a great opportunity to take this application and migrate it to C# as a way of giving the Java developers a migration path, give them something that they're comfortable with in understanding how to do development in .NET. So we had this book ahead of time at the company, and we were already familiar with the program, so we got a couple developers together. And over the course of the past 5 weeks, we literally just finished the project just recently. Over the course of the last 5 weeks, we proceeded to really understand what this application is about, to make sure we duplicated the functionality, but doing it in a way that makes sense for .NET. And at the end of the project, we were pretty surprised at the results. We, along the way, we implemented a XML web service. We also added mobile forms to it because it was so easy to do. At the end of the project, we thought we'd get an idea of the relative complexity between the .NET version and the Java version. So one of our guys wrote a little program that went through and counted all the statements, all the lines of code. And interestingly enough, our application was 1/3 the size of the Java program, doing the same thing, plus web services and mobile form development. Thank you. We didn't count the semicolons. No, I'm kidding. And what's really interesting, though, are the numbers for the middle tier, because that's where all the real work takes place. And you'll see that the numbers, we've got roughly 1/8 the amount of code.
Why is that? That's a dramatic difference.
We were puzzled, too, because we thought maybe it had something to do with the model view controller architecture in Java, or the beamed managed persistence architecture, or the fact that it's just a little bit of a heavier-handed architecture. But I think a lot of it has to do with the fact that we're able to take advantage of new features in ASP.NET, like data-bound server controls and dragging and dropping them onto the surface. Or we also used user controls to reuse some of the common UI, like doing searching and product catalogs and lists. We're able to use the ASP.NET forms-based authentication. So at the end of the day, you can see we had a lot less code, which is pretty surprising. So the next step is, how well does this do in the lab? Now, we've done several best practices applications where we've done benchmarking. How many of you are familiar with Fitch and Mather Stocks or iBuySpy? We did those applications, and what we found that if you can have an architecture with best practices with a small code size, yet at the same time have it be high performant, you've got a really winning combination. So we thought, well, let's take Oracle up on their 9i App Server challenge. They went and took the Java pet store application, did some benchmarking. We replicated equivalent hardware. They were, the blue line that you see here comes straight from the Oracle PDF, which you might not find on their website after I show these numbers. What they did, they cut off the testing once the pages were coming back longer than 1 second. So how many users could they support with pages coming back in less than a second? Well, they peaked at about 450 users. Okay, so we go in the lab, let's crank it up. How many users can we support? What's our page response time when we hit 450? Well, I told you about zero-based arrays. This number is actually 35 milliseconds. And for the very few of you that can't do long division in your head, 1,000 milliseconds divided by 35 is a very big number. It was 28. It's a factor of 28 times faster. We're scratching our head. Maybe it's the heavy-handed EJB code in there, kind of like the slower herbivores and the terrarium. I'm not sure what it is. So we said, let's let this thing rip. How far can we go until we cross the 1.0 threshold, the 1 second threshold? We got up to over 3,000 concurrent users. That's 6 times more capacity. Thank you. So how can 2 guys from Vertigo do this .NET development in 5 weeks and beat the pants off these guys? I don't understand it. So everything is fully disclosed. I encourage you guys to go to got.net.com, download the source code, see how we did it. If you want to use the design patterns that we discovered in your own applications, rest assured we think they're pretty fast. We'll probably continue to tune them over time. We did no tuning of this application in the lab. We simply didn't have time. We couldn't change the code. It was locked down. The end of the project, just last week, one of our developers, the guy had never done any .NET development before, thanked me for giving him the opportunity to work on this project. And it reminded me of a scene from Seinfeld. There's this great scene where Elaine and Jerry are late to an airport and they want to catch a flight, and they check in. There's only 2 seats available. There's one in first class and there's one in coach. And Elaine's begging, please let me have the first class seat. I've never been in first class before. And Jerry says, well, then you don't know what you're missing. Takes the ticket and gets on the plane. .NET is a first-class development platform. And if you're not programming in it now, you don't know what you're missing. I encourage you to get this code, play with the platform. If you're here today, you've made a commitment to develop on this platform. So have a good time.
Thanks, Scott. I think using .NET makes you the master of your own domain. Okay, let's talk about another area that, like performance, covers the entire framework, and that's .NET security. And this has been a challenge for us. You know, we come from a heritage where the ecosystem wasn't geared towards all these web service applications. PC applications in the past were generally isolated. Most servers were typically behind firewalls and never, punched through and exposed. And so we had to take a step back and really think through some of the .NET security design principles. Clearly, we wanted to provide a secure execution environment, things like managed code, code signing and authorization. We knew we wanted to leverage proven security standards, things like Kerberos, X509 public key infrastructure, SSL. But we knew we had to provide leadership on modular web service security standards, specifications like XML signature, XML encryption, and now our recently announced WS security spec. But security is not just about features. It's also being prepared for ongoing security updates. Well, in the .NET framework itself, we kind of break it down in a few simple questions and problems. The first is who wrote the code, right? Code signing is there, and we use it with strong names and certificates to guarantee code authenticity and to prevent tampering with the code. Then we look at how the code should be authorized. And again, it's flexible. You can use X509, Kerberos, or any other pluggable methods that you want for doing the authorization. We've built an industry initiative for building and maintaining these trust relationships called the Internet Trust Network. This is the work that we're doing with the industry and the ecosystem as a whole in order to federate Passport to build a secure Kerberos distributed infrastructure. We look at what actions the code can perform. So we have an evidence-based model, which I showed you in the CLR walkthrough. It allows the application to set policy and also the administrator to apply policy to the code as well. And finally, we think about who is executing the code. And here, the .NET framework took a role-based model, and so we provide APIs that are role-based for both authorization and authentication. And of course, we have all the other things you'd expect from a complete security framework, things like encryption as well. Well, the security commitment, as I mentioned, is not a one-time thing. It's an ongoing effort. And so we have the Secure Windows Initiative, which is an internal process that we use that focuses on delivering higher quality, more secure software. And we perform ongoing security assessments now. We also took a slightly different approach as we developed the .NET framework in that we worked with domain experts and partners in the field. So some of you may know Foundstone, which is a leading information system security firm. They work with the Department of Defense, the Air Force, the Big Five. They publish the popular book, I think it's called Hacking Exposed. It's actually on Amazon.com's bestseller list. They work on the weekly Security Watch column for InfoWorld. And we had them do a full audit of the .NET framework. Not just the architecture, but also we gave them complete access to the source. And they'll actually publish their findings for you to review in November, but I just wanted to take a quote from their findings. Based on an extended analysis of the .NET framework, we're confident in the strength of the design and confident in the resources and motivation of the .NET framework team to address security with the utmost priority as enterprise and web computing needs continue to evolve. So as I said, this is some design work we've done, but we're going to make sure that the .NET stuff is part of our ongoing framework and ongoing programs. So we want to provide customers with the tools and resources and support to both get secure and stay secure. And we'll make sure that .NET framework is part of the Stay Secure commitment, make sure it's part of Windows Update and all those ongoing services that keep enterprises up to date. Well, one of the reasons that security was so important to get right was the creation of our own set of web services, which our flagship services are called My Services. They provide great client support. As I mentioned before, that we federate at the corporate boundary. And so we started off building these services. We started with SOAP. We added the ability to transport binary data, so we got some better performance. We added logical service name that mapped the underlying implementation to route requests, so we got better scalability. We added a way to sign and authorize messages, so we had great security. And of course, we added a way to do alerts, so we could make all these cool demos work. And when we were done, we made sure that we had great .NET Framework and Visual Studio support, so you can just sit in the IDE and call Passport or call any My Service, the alert service, or any of the 14 that we're working on. Let's take a look at a simple example from one of the My Services. I happen to have picked My Contacts, but I could have picked any one. It's basically the same stuff you've been seeing all morning. It's just a simple SOAP message going over HTTP or maybe TCP directly. It hits the service logic. The service typically calls an XML store. In our case, we use SQL Server. We use the standard routing headers, security headers, license headers, application headers. Everything from our GXA announcement is used to build My Services, right? We build our services using our architecture. Let's actually get a better look at it than the slide. I actually want to call Mark Lukuski out, who's the Chief Software Architect for the My Services, and he'll give us a demo of what this stuff is really about. Thanks, Mark.
Hey, Eric, thank you. So this zero-based array thing, one-based array, where does that come from? There's only one answer, and it's zero. So let's put it to bed. My name is Mark Lukovsky. I am the Chief Software Architect of the .NET Services project here at Microsoft. Now, in 1988, Dave Cutler and I left Digital Equipment Corporation to come to Microsoft to design and build Windows NT. Dave did the kernel, and I did most of the executive and Win32 and a lot of the user mode support. So I'm a hardcore kernel guy. About a year ago, I left the Windows organization to come work on .NET. And my friends in Windows, to this day, give me no end of grief. They said, Mark, you know, what's gotten into you? You're in the land of teddy bears and fluffy clouds, and you allocate memory and you never free it, and there's garbage collectors, and what's that all about? Where do the bits actually go when you leave scope?
There's a big bucket behind stage.
I don't know. I don't know the answer. I mean, I just started writing in JavaScript, and you pop, and I don't know where it goes. Dave Cutler also used to give me a lot of good advice. And one of the pieces of advice he gave me is, Mark, if you're ever in a meeting, and during the meeting somebody says the word schema, just get up and run like hell, because if you stay there, you're going to get converted. So you can imagine how weird it is for me to be in a group where everything we do is about designing schemas, schemas for messages, schemas for data models, very strict data models and databases and stuff. So my life now is all about schemas. So why am I here? Why did I come to the .NET group? Well, I'm here because I am a total believer in XML. I believe it is the data format that is going to give us the degree of interoperability that we require. And it's the data format that's going to let me give to you guys a bunch of rich services that you can use, extend, transform, shape, and use in the right way for your applications. I believe that XML Web Services is the type of architecture that we need in order to bind these pieces of logic to one another when they're across different networks and they're on heterogeneous systems. And finally, I believe in the GXA initiative. I believe that we need a standard set of SOAP headers where we can use the word schema to describe what the format of the headers are and what the meaning of the headers are, and so that we can get that interoperability in areas like security and routing and reliability. So I'm a big believer in all of the work that's going on with .NET, and that's why I left Windows to come here. So what I'm going to show you with these little bits and pieces of applications is just a brief look at what happens with .NET My Services, what's really going on under the hood. And what I have is two client-side applications. I have a fake BlackBerry and a fake smartphone that are just simulations that make use of the .NET My Services. So let me power these guys up. I did that myself. That's a little timer in Java. You can do that. So I can click on the calendar and see calendar events for Mark. I can click on lists and see the list of things I have to do. I can do that for myself, and I can do that for others in my group. I can look at, I can shoot alerts back and forth. Now I want you to watch closely when I do an alert. I'm going to start an alert on the BlackBerry, and all the alert demos that you're going to see throughout the rest of this conference are probably going to show an alert with a blue piece of toast coming up. In a cell phone, you're not going to get the blue piece of toast. We're going to light up a little light in this area when we receive the alert. So type in the alert, I send it, and the alert came through, and I can see the alert and dismiss it. Now, with XML Web Services, any application that can form XML and speak the open protocols of the internet can play. So here I am, telnetted into a machine in Redmond that is running FreeBSD 4.3 release. And what I'm going to do is send an alert from Redmond to a web server running in the back, and it'll pop up an alert on, it should pop up an alert on the blue phone. And sure enough, there's the light. But before I go in there, let's take a look at the message. And you can see, here's the body of the message that I sent. And this is my response. And what I have here, I've got the alert on the screen. So let's open one of these things up. Being a kernel guy, I'm never going to go anywhere without a debugger. So let me pop this open, and you can see the actual messages. Let me enumerate a calendar, and you can see this is the message that I sent, the XML, and I have in here the routing header. Let me minimize that. I have the security header from GXA, and then I have my own application-specific header that I'll pop out of the way. And then in the body is just an application-specific message that's asking for calendar information for a particular date range. And what I get in response to that calendar information is a set of XML nodes that describe the calendar events that then I then transform onto the screen to draw this display. And all of our services work the same way, so that when I enumerate the lists, I'm doing the same basic message, only here I'm getting list information instead of calendar information. So that's kind of a brief view of what the .NET My Services are all about, and we'll be talking about these throughout the day. But the point that you should understand is that this stuff is easy, fun, and open. I mean, I wrote these applications. These took me all of a day or two, and most of the work was really figuring out how to position that little window, you know, on top of the skin that I have, and then how to hotspot in some buttons. So it's easy. If I can build an app like this, you guys can do wonders. And clearly, you know, we're big believers in XML in this set of services.
Thanks, Mark.
Thank you,
Eric. Well, I want to build on something Mark said. Mark mentioned that it was fun and simple. And if you think about some of the reasons that the internet kind of took off the way it did, I think that really was at the heart of it. You know, it kind of made playing with computers and writing code and developing fun and simple. You know, I think back to the first Windows program I wrote. I don't know how you guys did it. I actually got a copy of Petzold's book, typed it in, pretty much colon for colon, character for character, and voila, you know, I had a Windows app running on the screen. That was kind of amazing. And then, you know, VB came out, and I remember, you know, VB came out. I dropped the form. I got in. I wrote my one-line, you know, message box code, and wow, you know, I had a Windows app again, and that was a lot easier than Petzold. And you think about writing a web service now, and the first time you write a web service, and you can just sit down with Notepad, kind of write 5 lines of code, and save the file off, and voila, it's a web service. And that same joy of getting something up and running and being able to experiment and being able to use it from different devices and different contexts is something that I think is important that we hold dear to us as we think about, you know, what set of products we build going forward. You know, we really want to hear your feedback. I think it's important to have a little fun as we do work. One of the things that can make coding more fun is great tools. And Visual Studio, I think, is the best tool that we've ever built, flat out. It's rad for client, server, and services. It leverages your existing skills that you already know from Visual Studio, and we have great support for building distributed solutions. It's not just our work that makes the tool set so great. It's enhanced by partners, people like CompuWare, RationalWise. In fact, we have over 60 partners, and we'll be launching over 124 products in the Visual Studio Integrators program. Well, web services are here today. And we want to be clear that when you get home, you should start writing web services. But we did want to spend a few minutes sharing our ideas for the future. We want to make it even easier for applications to span organizational boundaries. We want to enable dynamic application topology. Enhancements for routing and security and performance make this possible. We want to build and deploy web services on distributed application networks. And we want to enable the next generation of tools that make it even easier to work together on projects, to test, to deploy moving forward. I actually wanted to drill down a little bit on the dynamic application topology and talk about what we mean and talk about deploying a web service into an operational framework that can be flexible. So to help me do that, I actually want to invite Vic Gondotra back out on stage. And he's here to give you a sneak peek of some of the futures of global web service architecture.
Great, thanks. Hi again.
Hey, Vic.
Hi.
Welcome back.
So, you know, everyone here knows that we're just about to ship Visual Studio.NET and the .NET framework. And, you know, I can't tell you how excited we are that you'll finally have this great tool in your hands. But even on the eve of releasing the first generation of the .NET framework, we're hard at work building the next generation. And I guess I get the fun job of giving you a sneak peek into what's going on in the dev labs back in Redmond and share some of our thinking. Obviously, we're hard at work thinking about the unique challenges associated with web services development. In fact, let me show you just some of the challenges that we're working on. Let me switch over here and bring up this application. So the scenario you're looking at here is a portfolio management application built by an East Coast brokerage firm. Now, it's easy to imagine that when the developer wrote the application, the entire application, that neither the developer nor the deployment folks really knew how popular this app might become. Really, you know, who can blame them? If you've ever done distributed development, you know that while you try to model behavior, Until you deploy the app and you see real usage patterns, it's incredibly difficult to really know. And few people have the time to go build into their application code all the necessary hooks to handle any arbitrary amount of scale. Well, we are working in future generations of the .NET framework to provide, as Eric mentioned, dynamic application topologies. Dynamic application topologies. What that means is that we're going to make it very simple for the underlying .NET infrastructure, that fabric, to automatically bring up servers as scale requirements dictate, to automatically have clients know what is the best available server to connect to. And here's the kicker. We think we can do much of this without requiring additional code on the part of the developer. Now, in this particular scenario, the East Coast company, the brokerage firm, built the app, and sure enough, they were wildly successful. They have more clients than they expected using their tool, and those clients were geographically dispersed all around the world. Now what do you do? Well, you can add servers. Obviously, there's latency issues. There's performance issues. You can put servers closer to your end users, to those clients. But what do you do about the code? Your code doesn't know about those servers. You got to go back, rewrite, rewrap that application logic code, think about that new topology you're going to support. But not this app. What we're going to show you here is, because it's built on a future generation of the .NET framework, the dynamic application topology support that it has. I'm going to bring up my network operations control panel here, put that up in the corner. A couple of things to note. You'll note, actually, let me just switch back here. If you look at the app, this is a debug version of this portfolio management tool. You'll note that the quotes window, my portfolio, is talking to a New York web server, as well as my news service is talking to a New York web service. And sure enough, if you look at my network operations control, you can see that that web server is pretty maxed out. Now, imagine having the ability to put up servers on the West Coast. Remember earlier we talked about new standards such as WS security, routing, referral protocol that allow us to establish code that runs through trust boundaries, organizational boundaries. That's what we've done. We've purchased some of those servers, they're being hosted, and now what I'm going to do is I am going to bring up those servers. Okay, keep your eyes right here as those servers come online. Now, what's going to happen is we're going to distribute out the news server. The news service, hopefully this will work. There we go, excellent. You see those Seattle servers come up? And you can see the corresponding drop in load on the New York server. Well, what just happened? Well, a couple of amazing things. Number one, because the news alerts are stateless events, this future version of the .NET framework knew that it could fan them out. And it went ahead to those servers, recognized that they were available resources, used them as fan-out servers for those alerts. Now, if that wasn't cool enough, did you notice a very subtle thing? Look at the app. The app dynamically connected to the appropriate server and automatically went to that Seattle server. That's pretty cool stuff. But let's make the scenario even a little bit more difficult. We look at the server logs, and we recognize that much of the server load is coming from Europe. And there's obviously latency issues going across the Atlantic. And we want to do some load balancing. But in this case, we don't just want to fan out the events to the European servers. We want to do something a little bit more complicated. We want to move and partition the application logic and move that to the European servers. Now, this is a bit tricky. Obviously, you can think of the challenges. You got data, you got to package up the data, bring that data out to the European servers. That includes the session state regarding each portfolio. Eve of releasing the first generation of the .NET framework, we're hard at work building the next generation. And I guess I get the fun job of giving you a sneak peek into what's going on in the dev labs back in Redmond and share some of our thinking. Obviously, we're hard at work thinking about the unique challenges associated with web services development. In fact, let me show you just some of the challenges that we're working on. Let me switch over here and bring up this application. So the scenario you're looking at here is a portfolio management application built by an East Coast brokerage firm. Now, it's easy to imagine that when the developer wrote the application, the entire application, that neither the developer nor the deployment folks really knew how popular this app might become. Really, who can blame them? If you've ever done distributed development, you know that while you try to model behavior, until you deploy the app and you see real usage patterns, it's incredibly difficult to really know. And few people have the time to go build into their application code all the necessary hooks to handle any arbitrary amount of scale. Well, we are working in future generations of the .NET framework to provide, as Eric mentioned, dynamic application topologies, What that means is that we're going to make it very simple for the underlying .NET infrastructure, that fabric, to automatically bring up servers as scale requirements dictate, to automatically have clients know what is the best available server to connect to. And here's the kicker. We think we can do much of this without requiring additional code on the part of the developer. Now, in this particular scenario, the East Coast company, the brokerage firm, built the app, and sure enough, they were wildly successful. They have more clients than they expected using their tool, and those clients were geographically dispersed all around the world. Now what do? Well, you can add servers. Obviously, there's latency issues. There's performance issues. You can put servers closer to your end users, to those clients. But what do you do about the code? Your code doesn't know about those servers. You got to go back, rewrite, rewrap that application logic code, think about that new topology you're going to support. But not this app. What we're going to show you here is, because it's built on a future generation of the .NET framework, the dynamic application topology support that it has. I'm going to bring up my network operations control panel here, put that up in the corner. A couple of things to note. You'll note, actually, let me just switch back here. If you look at the app, this is a debug version of this portfolio management tool. You'll note that the quotes window, my portfolio, is talking to a New York web server, as well as my news service is talking to a New York web service. And sure enough, if you look at my network operations control, you can see that that web server is pretty maxed out. Now, imagine having the ability to put up servers on the West Coast. Remember earlier we talked about new standards such as WS security, routing, referral protocol that allow us to establish code that runs through trust boundaries, organizational boundaries. That's what we've done. We've purchased some of those servers. They're being hosted. And now what I'm going to do is I am going to bring up those servers. Okay, keep your eyes right here as those servers come online. Now, what's going to happen is we're going to distribute out the news server. The news service, hopefully this will work. There we go, excellent. You see those Seattle servers come up? And you can see the corresponding drop in load on the New York server. Well, what just happened? Well, a couple of amazing things. Number one, because the news alerts are stateless events, this future version of the .NET framework knew that it could fan them out. And it went ahead to those servers, recognized that they were available resources, used them as fan-out servers for those alerts. Now, if that wasn't cool enough, did you notice a very subtle thing? Look at the app. The app dynamically connected to the appropriate server and automatically went to that Seattle server. That's pretty cool stuff. But let's make the scenario even a little bit more difficult. We look at the server logs, and we recognize that much of the server load is coming from Europe. And there's obviously latency issues going across the Atlantic. And we want to do some load balancing. But in this case, we don't just want to fan out the events to the European servers. We want to do something a little bit more complicated. We want to move and partition the application logic and move that to the European servers. Now, this is a bit tricky. Obviously, you can think of the challenges. You got data, you got to package up the data, bring that data out to the European servers. That includes the session state regarding each portfolio, its associated events. You got to go get those running over on the European servers, as well as you have to have those clients do this same amazing ability, which is now to know to connect out to those European servers. Well, let's see what happens as I bring up those European servers. Okay, I've initiated that call, and keep your eyes there at the bottom here as those European servers start to come up, as well as on the load on the New York server there. Okay, there you have it. Those servers in Europe have come up, and the load in New York has gone down correspondingly. Now, obviously, that took some recoding. That doesn't just happen magically. It will require the developer to go and think about how they partition their application logic. But in future versions of the .NET framework, we're going to provide tools that make it much more simple for you as a developer to mark which sections of your code can, in fact, be application partitioned correctly. So you've seen fan out of stateless events. You've seen application partitioning. What about the flip side of that problem? What happens when a portion of your infrastructure goes down unexpectedly? Well, if you note at that new server, it's talking to a Seattle, a WS1 server. Let's shut that down. Keep your eye on the graph here. There's a degree of latency here as we get these reports back. But if you keep your eye on that Seattle server, two things are going to happen. Hopefully. Oh, there we go. That one server goes down. The other Seattle server picks up that stateless event load, and note that we've automatically moved over without disconnecting that client, without requiring any downtime. And we brought that up. So let me just summarize here. A future version of the .NET framework is going to enable dynamic application topology. It's going to enable you to have clients that maintain connections in the face of adding servers or removing servers. It'll do that for stateless events, including application partitioning. And also, it'll support failover. Certainly, we think these things combine up to provide you extremely dynamic application topology. You know, our goal is to enable you as developers to focus on your business and really allow the underlying infrastructure to step up and meet the needs of your customers. Hopefully, you can see with .NET, we've only just begun. Thanks, Eric.
So a few points about dynamic application topologies. You know, some of this technology actually exists today, but really today it's only used on the largest public, .com sites. And I think it's important to realize there's plenty of value in thinking through some of these things in enterprise scenarios. I'll just speak from personal experience. If you take a company like Microsoft, we have literally scores of subsidiaries around the world, and we have typical line of business apps, how I manage my 401k, how I get a new card key, what flavor of soda to order. And if you're an employee in India or in China or in South America, you don't get the best application response times because those applications have to be hauled all the way back to Redmond. Well, why? Well, because it's too hard for our IT department to actually fan out these applications throughout the world, and it's too expensive to actually use a service provider just for some simple 401k app. What this architecture will let you do is make those scenarios much simpler. Later on today, Paul Flessner is actually going to show App Center, and App Center is the product that actually is used to manage these instances of dynamic application topology. So Paul's going to show you what's available today. This technology is for web services of tomorrow. So I think Vic convinced us that .NET has an exciting future, but it's also off to a pretty exciting start. I think we have some incredible momentum. We already have over 35 component vendors selling .NET components. There's more than 25 ASP.NET hosters. In print, by the end of the year, we should have over 150 books available on .NET. Currently, 4 of Amazon's 10 best-selling programming books are on .NET. There's 3 new dedicated magazines. We've had a phenomenal effort in training. There's over 815 institutions in the MSDN Academic Alliance. That's over 15,000 faculty and 200,000 students. So I think we'll be touching this next generation of programmers, and they'll be available in the workforce pretty soon. There's more than 50 companies that are already today offering .NET training, and by March, which will be our official, you can go in the store and buy it, we expect over 250 companies will be offering training. Finally, a word about community. We have over 70 user groups devoted to .NET, and literally hundreds of news groups and websites devoted to this. We love reading news groups ourselves at Microsoft. We're all active participants in my team. I know a lot of us spend time. And we love reading not just feedback from Linux users, but from Java users as well. So I hope to hear from you about your experiences, and we're pretty excited to get this feedback and to get the feedback loop going and to make better and better products. Well, in summary, I want to leave you with a call to action. First, make your bet on XML Web Services. It's here today. Connect your services together and connect them to my services and implement them using the new web service protocols. Build great solutions. Build applications that use clients, servers, and services with the .NET framework and the Visual Studio tools. Create the next generation experiences that run anytime, anywhere, on any device. And take advantage of the capabilities offered on the target platform. You must deliver the great user experiences. The lowest common denominator solution never wins, so take maximal advantage of the platform. And finally, give us feedback. I think we really win by working together. So talk to us this week and help us make .NET even better. There's over 500 people from Microsoft around the floor. You'll see us wearing our shirts. Get your PDC trading cards. You kind of saw them in the app. It's a good way to meet each other. We have some trading cards too. I'm sure we'd be happy to lose to you. I'll give you an opaque clue for the grand puzzle. My opaque clue is Androids. So if you want that signed t-shirt or that Xbox, start playing. But more importantly than today and just the PDC, engage in the community going forward. Specifically engage in the online community of the news groups, the list servers, the physical community of the user groups. Some chats we'll be hosting. Share your knowledge. Get help, give input to us on how to make a better product. We're online to listen and help. We'll link to partner communities that are healthy and vibrant. I encourage you to find out more about the .NET technologies on MSDN, on the community site on Microsoft.com, and on .NET.com. Work with us on marketing your solutions. The Windows XP co-marketing opportunities are documented below. The logo programs that we touched on in the earlier keynote are available as well. Well, in summary, we're very excited and confident about .NET, but we're not overconfident. We know that developers, you folks in the audience, will ultimately determine the fate of .NET. So I want to thank you for attending this year's PDC. I half-jokingly named my talk Nothing But .NET, but the truth is that at Microsoft, there really is nothing but .NET. We've bet it all on this strategy, and we've bet it all on working with you. We hope you believe. We hope you bet with us. Thank you.
When the World Trade Center collapsed, there was hundreds of thousands of circuits that were damaged in the Verizon building. Verizon, Agilon, and Infragistics came together very quickly to make enhancements to an existing application to be able to allow engineers to track all this equipment that they needed to replace.
For the past several months, Agilon had been working with Verizon, designing an application to track status of orders, circuits, things such as that.
Viper is a project that is designed to provide Verizon with the information necessary to manage resources. Typically, this solution would have taken at least 6 months to perform. We were able to provide the solution within 6 days.
The .NET framework allowed them to move exponentially faster than they could have with some other tools that we've used in the past. And additionally, I think that the components brought to the table by Infragistics further enhanced that effort.
They were able to turn this application around. I think that's a great testament to the stability of the .NET platform, as well as third-party community providing reusable components, and the talent of the IT capabilities of Agilon to deliver this solution.
You can't say enough about the turnaround time, the reusability of code, the ability to react very, very quickly to a very, very important situation.
Ladies and gentlemen, the next general session will begin at 1:15, which is an hour and 15 minutes from now. Thank you very much.